All right, so we've been working on trig identities in class, and when you're doing trig identity problems, you just want to keep using your different trig identities until eventually it all works out. So sometimes it's hard to know exactly where you're going, so just trying to stick with it. So here's the problem that a lot of people were asking me about. Cosine 3x minus sine 3x divided by 1 minus 2 sine of 2x. And somehow we're supposed to prove that all of that ends up being cosine x plus sine x. So what I'm going to do is I'm just going to use a couple of the formulas that we know. Like, for example, we know that if you did cosine of a plus b, you get cosine a cosine b minus sine a sine b. And if you did sine a plus b, you get cosine a sine b plus cosine b sine a. So those are just things you can look up if you have a hard time remembering them, which is totally fine if you have a hard time remembering those. Then there's another one that is really related to this, and the reason I'm going to use this other one here is because I see a sine of 2x. So I'm just going to remind myself, what do I do when I see sine of 2x or sine of 2a? Sine of 2a is the same as 2 sine a cosine a. I looked down at my textbook here and they had it written down wrong, but I know that it has to be this because if you look at the formula that we just wrote with a's and b's, if you make the a's and b's the same letter, you have 2 sine a and cosine a. So let's do that. Let's write the top thinking of 3x as being x plus 2 more x's. And so cosine a plus b is going to be cosine x cosine 2x minus sine x sine 2x. And then we're subtracting sine of 3x. So I'm going to subtract, and I'm going to use the sine addition formula, where I have cosine x sine 2x plus cosine 2x sine x. And then on the bottom, I've got that 1 minus 2 sine of 2x, which I could rewrite as 1 minus 2 sine x cosine x. Almost. I need another 2. There was a 2 here, and there was a 2 here, so I need to make this into a 4. Okay. Now, let's just keep going. If I distribute the negative, I'm looking for things that they have in common, and I'm going to notice that this term and this term both have a sine of 2x, and this term and this term both have a cosine of 2x. So I can factor out cosine 2x, then inside the parentheses are cosine x from this piece on the left and sine x from that piece on the far right, and it's a minus because I had this subtraction symbol in the middle. Then I have both of those other two terms have sine x in common, and they're both negative, so I can write minus sine 2x. And then I have here cosine x plus sine x. I really wish that those pieces on the inside matched up, but they don't. So we just keep going. Okay. Now I've got some cosine x's and cosine 2x and some sine of 2x that I can still convert. So let's do that one more time. Cosine of 2x is, we can write this as cosine squared x minus sine squared x. That's looking at this top formula here and just making the a's and b's the same. So that's multiplied by cosine x minus sine x. Sine of 2x we already talked about, so minus 2 sine x cosine x. And then here we have cosine x plus sine x. All that is still over this denominator, so it doesn't really seem like we've made very much progress. And that is how a lot of these trig identities problems feel. It just feels like it's getting worse and worse and worse. One of the nice things, though, about if you look at cosine squared and sine squared, cosine squared minus sine squared factors. Remember, if you do like x squared minus y squared, you can factor that to be x plus y times x minus y. So I'm going to think about that piece as cosine plus sine times cosine minus sine. Okay? Well, that gives me a common factor right here, because here's another cosine plus sine. So let's see if I can squeeze this into the bottom right corner. Probably a poor choice, but we'll give it a shot. Cosine plus sine was the common factor. Then I have cosine minus sine, and that thing is squared minus 2 sine cosine. Boy, that handwriting got really bad. Minus 2 sine cosine. And all that's over 1 minus 4 sine x cosine x. Now, one thing that's nice is that in my original problem, I saw that my goal was cosine plus sine, and I have a cosine plus sine. So now I just need to look at all the rest of this junk here and hope that it equals the number 1. Okay? So let me erase some of this stuff up here. Oh, that eraser is not working real great. There's probably a better way to do this. Come on, eraser. All right. And almost there. Okay, so I've got to figure out how to make this eraser work a little better. Is there a way to make that? That's okay. All right. So, all I need to do now is, let's see what this does. Yeah, that's great, okay. All I need to do now is get rid of that rectangle I just drew for no reason, and then finish out my trig identity up here. I'm just going to focus on the part that is in the circled part there. So, let's choose a nice orange color. If I look at cosine minus sine squared, that becomes cosine squared x minus 2 cosine x sine x plus sine squared x. So that's this part down here. Then I also had another minus 2 cosine x sine x. If you gather your like terms, you have cosine squared x plus sine squared x minus 4 cosine x sine x. And cosine plus sine, cosine squared plus sine squared is 1. So we have 1 minus 4 cosine x sine x, which this matches the denominator. So that all cancels out to be 1, and you have the piece that you wanted. So, obviously some of my sloppier handwriting, but the math's all good. You just keep breaking them apart. As I look at this, there may be a more elegant way to go through that, but that was the way that I just kind of kept chugging along at it.